So welcome everyone to the data engineering meetup. Due to COVID-19, we do a combined Brisbane, Sydney and Melbourne meetup, really across the whole APAC time zone. I'm guessing is probably when it's a good time for folks. We've got two really awesome speakers today with us from the Bay Area. Raghu Murthy, he's the CEO of Datacoral. He's going to be taking us through the three-step framework for building a modern data stack. So that's going to be really cool. And I'm sure he'll tell us a little bit about what Datacoral are and I guess how they help, migrating data from application databases through to data warehouses. I'm sure that's going to be really cool. And then Joao Correia, he's Solutions Director at SnowcatCloud. They specialize in Snowplow and have a SaaS app that you can sign up to ship all your event data from your websites through and other sources through to a particular destination, whether it's on-prem. He'll probably take us through a lot more of that as well. So his talk's titled Snowplow: the what, how, why, and when. We've also got another talk at 6 p.m. tonight, Australian Eastern Daylight Savings Time. So yeah, it's just because our speakers are scattered across the globe. We don't want our speakers waking up at 3 a.m. to present at our meetup. So we're trying to make life a little bit easier for them. And it causes us, I mean, if anyone can't sort of make one particular time slot, you can always catch up after the fact on YouTube. So hope it all works out well for you, but definitely do send us feedback. If you've got a preference for the midday or the 6 p.m. evening time slot, just let us know. But anyway, on the YouTube chat, feel free to just say hi, tell us where you're dialing in from. But without further ado, I might hand it over to Raghu. Take it away.
Thank you so much, Peter. So I'll start sharing my screen and then get with it. So please let me know when you're able to see my screen. It's not full screen as long as you have the content visible. I'll try not to kind of mess with.
No, that's fine. Yeah, that works out perfect. I'll leave you to it. Thanks, Raghu.
Awesome. Hi, everyone. Thank you for giving me this opportunity to kind of speak with you about a few things. One, the main thing about, which is the title of this talk, is about a framework for building a modern data stack. I'll also spend a little bit of time later on talking specifically about Datacoral, but the first several minutes of the talk are mainly going to be about just thinking in terms of the overall landscape of tools that are out there. How do you think about even piecing them together? So that would be my overall topic. A little bit about my background. So I've been working on data infrastructure for about 20 years, a little over 20 years in Silicon Valley, starting off at Yahoo back in the day, where we ended up building a SQL engine to replace Oracle because Oracle was too expensive for analytics. And then later on, ended up working at Facebook, where this time around, there was the big data movement that was kind of happening overall in the industry. As part of the initial team that built an open sourced Apache Hive, which is a SQL engine on top of Hadoop, which is a MapReduce framework. This is all kind of now so old that a lot of these technologies have since been I guess superseded by some of the newer technologies that have kind of come out. But a lot of the technical learnings, or like the newer tools, have actually leveraged quite a lot of the learnings from these older technologies that have been kind of part of building. So at Facebook, it was not just building out these technologies; it was also running a data infrastructure stack at scale and solving a lot of the business problems that Facebook had during its kind of explosive growth years, starting from just data anonymization. This was even before there was GDPR. Facebook had started working on anonymizing all the data in their data infrastructure. And then I ended up also working on making the data infrastructure stack, which is just which used to be just one Hadoop cluster, and turn it into a multi-tenant in a multi-data center kind of set of deployments. A lot of learnings, a lot of fun kind of building all of that. And then after that, I was an EIR at a VC firm based out of the Bay Area called Social Capital. And I ended up talking to a whole bunch of companies that were trying to leverage their data. They knew that they had data in different places, but they were trying to get value out of it. And they were, in some sense, kind of figuring out what were the tools that they had to kind of piece together. So this is about 5 years ago now. So my take, and you may have seen kind of different versions of this in the past too, is that companies that are trying to become data driven, they cannot just go from data to value in kind of one step. You have to actually take data through its phases, if you will. So you might have in a company data sitting in like very different places. So you first have to centralize it, maybe get it into like a data lake or a data warehouse before you're able to figure out what the data means. So that is when you end up maybe computing some metrics, try to understand exactly what the data is. And only then can you even think about building machine learned models and then get really sophisticated and ultimately predict and improve outcomes. So it's essentially a hierarchy of needs, because you can't really just go to the top here on trying to predict and improve outcomes before you have kind of the bottom layers figured out. And it's a pyramid because turns out a lot of the engineering work that needs to be done to take the data through its phases is actually building out this data stack, as it's called. And a lot of the engineering actually happens in the underlying and the lower levels of this pyramid. And in our mind, it's the data engineering teams within these companies that are tasked with building the data stack to support the business needs of the company. Right? So now when you think about what exactly it means to build a data stack, there are many takes. There have been quite a few things written about how to even think about building out a data stack. So there's even clearly like the talk of a modern data stack, where this is a picture from Andreessen that it was like a really amazing kind of thought piece around how to think about piecing together different tools that are out there in the market. So it turns out even when people are trying to put these things together, it takes it looks pretty intimidating, right? So a company that is trying to set up their data infrastructure stack, they look at the number of different components that are here and how interconnected they seem to be. It's really hard to figure out which combination of tools to actually put together for the specific needs that are there in that company at that point in time. And also, it needs to kind of survive or enable the company to kind of grow. Maybe for the next 2 to 3 years, this stack has to actually just work and grow along with the company. So my take was that maybe if the way to think about a data stack becomes this kind of complicated, it's actually pretty hard to reason about things. So maybe it's time we can rethink how to build a data stack, right? Not that you rebuild the entire thing. It's about how do we even think about building a data stack, right? So that was the kind of the beginning of this framework that I've been kind of thinking about and recently wrote about in Towards Data Science. And the framework this is more of a kind of a theoretical or like an abstract kind of framework, right? So there are no specific tools listed here, deliberately so, because trying to fit all the tools into this kind of 3-layer stack is actually almost like an exercise in futility, because a lot of the tools themselves have not been built with kind of this 3-layer kind of framework. So the reason for us to kind of talk about it now is to essentially start a conversation, right? And see if this makes sense see if there are things that we are missing. A lot of this is based on just our own experiences, having worked in companies building data infrastructure, as well as talking to a bunch of companies over the past few years and learning about their problems. So I won't go into every single detail here in terms of what is in every layer of the stack, but I'll just cover the each of the layers in a broad strokes. And if there are any questions, definitely happy to kind of answer them as they come along. The layer that everybody is kind of familiar with and everybody knows about and thinks about is the data flow layer, right? So this is where people think about building a data stack. Is first of all getting some ingest tools that are centralizing data from different sources into a data store, and the store is either a data warehouse or a data lake. And then you have the transformation tools, or the ability to kind of transform data within these data stores. And once the data has been transformed, and these transformation tools are kind of combining both the SQL-based kind of transformations that are run inside of a data warehouse, as well as even kind of pretty complicated things that you do, like doing model building and even maybe inference calls and so on. Those are also technically, we're kind of putting that into a transform kind of component of the data flow layer. And once the data has been kind of transformed and aggregated, and then you end up trying to visualize the data, or you can choose to publish that data back into destinations. So nowadays, this is being called reverse ETL, right? So this is your data flow layer, right? So it seems kind of pretty straightforward. Then the question is, what are the next set of things that you have to actually worry about? And this is where the metadata layer kind of comes in. So in the metadata layer, it's what you assume to be kind of the standard metadata, which is both things like schema, what are the tables, what are the columns, things like that. And then you start getting a little bit deeper in terms of what is the lineage between different data sets, or how do you, what are the statistics about the data that is actually flowing inside of the data flow layer. So all of this type of data is actually stored in metadata systems separately or inside of these tools themselves, and they offer it when they provide their own visibility or like their own observability. But when you think about a metadata layer, this consists of a lot of the data that, or a lot of the metadata that corresponds to the data flow, as well as a couple of things that we have included in the metadata layer, because in an opinionated way, we believe that this is like something like an orchestration should be in the metadata layer. I'll get into a little bit more detail about what it means for orchestration to be in the metadata layer. But the general idea is that if you want to trigger jobs or tasks, or if you want to trigger transformations, for example, you want to know that the data is fresh. And the only way you know that data is fresh is by looking at, let's say, statistics, right? So just this is like a very small glimpse into like how we think about orchestration in general. There are plenty of other orchestration tools and their own kind of opinionated ways of kind of doing things. But we are we believe that orchestration should be firmly in the metadata layer. The rest are kind of access control, auditing, observability. So these are all, again, if you remember the previous screen, they're all kind of things that are said to be needed. So they're just kind of stuck away somewhere outside of this kind of overall data flow. And just mention that, yeah, these are things that you will also need to add. Not very clear how or where they need to be added, just the fact that you need them in your stack. So in our mind, this corresponds to the metadata layer. And then the top one is probably the most obvious one, especially if you're an engineer, is kind of your DevOps tooling layer. How do you author any aspect of this kind of data flow, either ingestion or kind of transformations or even kind of publishing? Maybe you build your own visualizations. What is your authoring flow? How do you test it? Test the code that you're writing, or configuration even. How do you test the configuration? How do you deploy your changes, and how do you ultimately monitor them? So this is the overall framework that we wanted to initially kind of propose. and see if this makes sense, and definitely start that off as a conversation. So to make this concrete, I just wanted to take an example data stack that is fairly popular nowadays. We are actually, like, I mean, given that I've been in this space for a while, I've known a lot of these tools kind of mature over time, and I think they've become like really awesome tools that the entire industry is kind of moving to. So to, just as a setup, a sample kind of data stack um, would look something like, use a tool like Fivetran, which is a data integration provider, to be able to centralize data from different sources, like your Postgres database or Google Analytics, Stripe, or whatever else, into a data warehouse like Snowflake. And within Snowflake, if you want to get the raw data to be transformed and build and model the data, clean the data, then you use a tool called DBT, which is a data build tool. They offer a way where you can just specify SQL, and they have and you define things like views and views on top of other views, and they have a way to kind of refresh these views whenever the underlying data changes. But there is some nuance to kind of how to actually make that work, and that nuance tends to be a workflow manager. And an example workflow manager that has been like fairly popular is Apache Airflow. And this workflow manager is used to essentially schedule these DBT model refreshes depending on when the underlying data might change. And ultimately, when you're trying to kind of visualize the data, Looker is a pretty popular tool. Right. So now, given this stack, let's kind of go back and look at each of these tools, basically in terms of the three-layer framework that I just kind of talked about. So there's a lot that goes on here. I'm sure we'll be sharing the slides later too. The main thing to note here is that each of these tools
Have you gone on mute, Raghu?
No. Are you able to hear me? Are you able to hear me? Yes. Okay. All right. Cool. Right. So like when you think about each of these tools, they've all been built kind of as independent kind of solutions. And in order to, sorry, are there any questions or?
Sorry, my bad.
No worries. All right, no worries. Yeah, so when you think about each of these tools, because they've been built in a fairly kind of independent manner, you start seeing that they've actually built software in pretty much every single layer, right? So I won't go into every single one of them, but I will maybe talk about two of them and kind of show you how there is almost like a split brain when you're working with kind of multiple of these tools. So if you think about something like Fivetran, I mean, they provide like a pretty amazing set of connectors that are able to load data into Snowflake. And of course, like in order for them to build their own data integrations, they need to manage the like how the data is getting pulled. So they have built their own kind of orchestration, typically driven by scheduling, as in like run something every hour, every day, things like that. And in terms of kind of the DevOps tooling layer, it's mainly about configuration, right? So they have a web UI in which you can kind of make changes to the configuration. All of that configuration is clearly sitting in their systems. And one of the things that you'll notice, and I'll keep kind of coming back to this as well. Like, for example, if I'm changing configuration in Fivetran, no other tool really kind of knows about it, right? Because all of the configuration is actually sitting inside of Fivetran. So now let me go to the almost the other end, which is something like Airflow, where it's a workflow manager. It is used to orchestrate jobs and tasks that need to be run based on like dependencies. So it doesn't have any kind of specific data layer capabilities, data flow layer capabilities itself, although some people have built out some kind of operators that are moving data. But Airflow itself is purely about the orchestration. But then Airflow itself doesn't really have any notion about the data itself, right? So it doesn't know what data freshness means. I mean, Airflow inherently doesn't know about it. People have to write code to make it so that when jobs are run, if the jobs depend on some data, code has to be written to make sure that the data has arrived before the job has been triggered, right? So Airflow has this notion of sensors and so on. So as you can see here, like for each of these different tools, if they provide their piece of functionality that works really well, and they have optimized how the metadata for their own kind of specific pieces of functionality, they're optimized for that. But then if you want like an end-to-end view, like a single pane of glass view, your only option is to bring in another tool, which is just integrated into uh, uh, any of these tools that are kind of coming, try to pull data out of these tools. Sometimes it's possible, sometimes it's not. And those other metadata tools end up becoming these kind of read-only tools that are available. And it almost becomes like documentation in code, right? So metadata might go stale, and metadata is only as useful as the quality of the metadata itself, right? So for the most part, these metadata systems end up becoming, like the use cases end up becoming more around searching or auditability or compliance and things like that. So when you, I see a question here. So Peter, maybe you can kind of help out here. So do I end up answering questions right now, or do I kind of go through this and then, I don't know what your format is.
It's whatever you prefer, whatever you're comfortable with. Some speakers prefer to just kind of save them all to the end. But if it sounds like you're a total pro and you're all over it, so absolutely go for it.
Yeah, absolutely. So yeah, so the question from James was that how do you handle real-time data with the stack? So you don't. So this was just a stack that we just kind of talked about just as an example. I will talk about how to think about metadata first in streaming systems as well. So just maybe remind me if I don't kind of get to it towards the end. So when you think about kind of the challenges with siloed metadata, talked about this split brain problem. The orchestration is kind of inconsistent across tools. Fivetran has its own orchestration, DBT has its own orchestration, and now you have Airflow that is sitting on top that is also trying to orchestrate these jobs that are running between these two kind of tools. And like I mentioned, the workflow manager, there's a bunch of coding that is needed. And the thing that becomes hard are all of these kind of non-sexy kind of activities that are literally the day-to-day challenges for everyone, right? So how do you propagate schema changes? Like something changed in the source in terms of the structure of the data. Maybe Fivetran knows about it and can handle it. If it does handle it, does DBT know how to handle it? Are the transforms kind of able to kind of, are we able to notify the authors of the transformations that, hey, your source data has changed? Or if you're trying to do historical syncs, how do you propagate historical syncs from your connector through your transformations, ultimately to even maybe publishing data back out to destinations? So the authoring itself is like pretty hard. Like when you're making changes, you don't really know what you might break. There's a bunch of work that is happening around testing, but tests are just that, tests. But we have seen so many cases where the tests succeed, but then you put it into production and it fails on day one, mainly because the data volumes are too high. There's just not enough time and, or maybe there's just not enough CI/CD kind of tooling in place to allow for testing in kind of big enough kind of data volumes for you to be able to see what the problems can be. And the last part, and this I'll get into a little bit more detail, and this is also something that I wrote about in the post, is debugging things becomes like pretty hard, right? So I'll again like quickly kind of go through this. So here the scenario is that setup that I talked about: Fivetran to get data in, DBT to transform, Airflow to kind of orchestrate, and then ultimately Looker to kind of show dashboards. So now we are going in reverse when you're debugging problems, right? So a business user is looking at a Looker dashboard. They see a problem. So now what do they do? the first thing they do is inform the analyst who created the dashboard to say, hey, looks like this particular number in the dashboard just does not make sense. What gives? So the analyst, the most that they can do is look at Looker and figure out whether the query in Looker makes sense or not. If it does, uh, uh, or if there is a problem, then they go fix the query and then things are fine. But if there is no problem in the dashboard query itself, then in many cases, the analyst has to hand it off to somebody. So typically, it would be somebody like an analytics engineer. And the analytics engineer now goes into DBT. They look at what is happening inside of DBT, look at the logs, look at kind of what, if there are any kind of model queries that have to be changed or whatever. If they don't find a problem there, then they now hand it off to someone like a data engineer who now knows how to work with Fivetran or any other connectors that they may have. And the data engineer kind of goes through the same process of, okay, looking at the Fivetran logs or system tables that it produces in Snowflake. If there is nothing wrong with Fivetran, then they'll have to go look at Airflow to see if the orchestration was off, go fix the Airflow DAG, or go fix Fivetran. And ultimately, if nothing is actually, if they see that the problem is, let's say, in a source system or something like that, then they hand it off to kind of their DevOps teams and figure out if something goes wrong there. So this whole kind of debugging flow, if you will, as you can see here, involves way too many people and too many systems that you have to kind of jump across, which then means that it takes time, and every single problem becomes like this kind of firefight that typically data engineers are doing whenever there are data quality problems. Okay. So the I'll kind of switch gears here a little bit and say, okay, because of these problems, the question is, how do you end up kind of solving these types of problems, right? So I talked about kind of the 3-layer framework. Again, it was like a fairly high level, kind of almost theoretical kind of framework. So what I want to present next is essentially like a blueprint for how to think about metadata first, right? How might you be able to build systems so that they can be metadata first? So it's the same kind of 3-layer kind of framework. In the first layer are basically your kind of the ingest tools, transform tools, and so on. But the thing that you see that are kind of fairly different here is that we have essentially made orchestration and the pipeline metadata be the core brains of the overall stack, right? So the idea here is that every single piece of functionality that you have in the data flow layer, which is either ingesting data, transforming data, or whatever, instead of each of these tools building their own metadata and their own kind of DevOps tooling layer or whatever, they're all reliant on this kind of pipeline metadata, which includes things like schema, lineage, statistics. And the orchestration engine is driven by this metadata. So it's based on data dependencies rather than it being explicitly coded up using kind of something like Python code or things like that. There's a lot of caveats to this, by the way. This can turn into like a really long kind of conversation about a bunch of what if kind of scenarios. And if you kind of dig deep enough, and I have in kind of in my previous roles, as well as kind of when we have talked to other people, what we have found is that thinking about orchestration being completely driven by the pipeline metadata rather than by schedules or anything else gives the metadata. So now the metadata becomes a critical part of your data pipeline, right? So it's in the critical path. And then what you can do is all of your kind of DevOps tooling layer, the entire kind of DevOps flow, if you will all be operating within the pipeline metadata, or will be operating on the pipeline metadata. So for example, when you're authoring something, when you're configuring a connector, let's say, so now you are making changes to configuration that is sitting in the pipeline metadata, the orchestration, whenever it decides to kind of trigger like a job or like an ingest tool, The ingest tool basically looks at the pipeline metadata to figure out what is the configuration that it needs to use to kind of fetch data from the source, right? Similarly, when you're building transformations, the SQL queries or like the data dependencies or whatever, they can all be stored in the pipeline metadata itself. And when you author a SQL query or when you author a transformation, the data dependencies are also what are stored in the pipeline metadata. And because the data dependencies are stored in the pipeline metadata, the orchestration can leverage it, right? And guess what? Those data dependencies are essentially what is data lineage, right? So now your, or at least schema lineage. So now when you think about things like observability or auditing, you see that you can directly just work off of the pipeline metadata without really having to have a separate system that provides observability or provides auditing kind of separately. Right? The same thing happens when you're kind of testing. So when you want to test, you can actually look at a lot of the, if your tooling has access to all of the statistics, then you can think of kind of automatically generating kind of these test pipelines that can leverage the these statistics to build appropriate kind of test pipelines before the changes actually are pushed to production. And now, even when you're pushing to production or deploying, the idea here is that you also need to figure out when to push your changes, right? So let's say you're trying to, you have a pipeline that has like an ingest kind of connector that is kind of pulling data every hour, and you're trying to change the configuration of the kind of the ingestion tool that is pulling the data every hour. And then there is a transformation that is running every day. So it's a daily report. So the transformation needs to wait for 24 hours of data to kind of show up before it runs. So that's if that were the setup. Now, if I want to change the configuration of the kind of the input or the ingest tool, I don't want to apply the changes to the configuration in the middle of the day, because if that changes the way that data is kind of being fetched into the data warehouse, then you end up having a transformation that is looking at kind of half old version kind of connector data and half new version connector data, right? So even the deploying of these kind of changes can be synchronized or can be can go in kind of lockstep of the actual pipeline execution itself. And what we have found, and we there's some of the things that we are kind of beginning to kind of implement inside of Datacoral as well, is that orchestration is the one that is also figuring out when to make the configuration or the changes that you're making, when to make them production. It kind of waits for the right time for it to do that. And ultimately, the monitoring becomes is kind of out of the box, because the pipeline metadata is now everything that you want to know about what's happening in your data pipeline anyway. So what we have done, hopefully this makes sense. Definitely, again, happy to answer any questions that come up. So this is still kind of theoretical, right? So this is just a way of thinking. If you start thinking about it this way, our belief is that you'll have a much more easy to understand and a more of like a coherent intelligence, if you will, inside of your data stack, where all the changes are going through this kind of central metadata layer. So there's a question here in terms of what is the CI/CD support that should be built into this concept. So CI/CD is basically this whole kind of deployment, how deployment kind of interacts with the pipeline metadata, right? So the way to kind of think about it is, whenever a change it needs to be kind of pushed, it is first staged in the pipeline metadata, right? And that staged configuration or the stage changes can be kind of used to do kind of two things. One is automatically kind of spin up new pipelines based on whatever changes that needed to be tested. Again, I'm talking super sophisticated now, right? So there is nothing that's there just yet, but it makes it possible for you to be able to do that. And the actual deployment itself can be triggered when it's the right time to do the deployment. Like a change has been staged, it's a consistent change, and there is a right time to apply the change when it won't affect anything downstream to go bad. Right? So that is kind of what we are going for. So I won't have too much time to get into like an exact example, but these are some of the things that we're actively kind of working on, kind of building out content around. Definitely happy to kind of talk to you about it separately, or you can kind of reach out to us. So we have taken this kind of a blueprint and built something at Datacoral that is more end-to-end. The first thing that we did was start off with this metadata layer. So we built a core engine that has a metadata store with data lineage kind of built in, and a metadata-driven data orchestration engine. And like I mentioned, because we started off with this specific kind of core engine, we were able to add pieces into the data layer like pretty quickly. Of course, we don't have everything that's under the sun. Like this is still the beginnings of a metadata-first data stack. But given that we have been able to build this kind of metadata and the tightly coupled orchestration, we've been able to build out a lot of connectors. We've built out about 80 odd connectors to kind of different sources. And these connectors, they're doing very little. They only have the business logic of how to fetch data. All of the configuration that they need is sitting in the metadata. All the that includes things like how often do you want the data, like how do you want to fetch the data? Are you fetching incrementally? Are you fetching it in a streaming manner? Are you batching it? How are you batching it? All of that information is actually stored in the metadata layer. And then the connectors are using that configuration to perform whatever operations they can. And we built out drivers into a bunch of the data warehouses or data lakes that are also relying on this metadata to figure out what are the transformations that need to be run whenever new data kind of arrives. So we've been able to make it so that orchestration is kind of built out, comes out of the box without really having to explicitly code it up. And we also built out a bunch of these connectors called publishers. Like I mentioned, nowadays they're being called reverse ETL. So we've been able to build this kind of the data layer and the metadata layer. And in the metadata layer, as you can imagine, because all of the metadata is there, we are able to provide data observability out of the box. We can provide like data quality checks out of the box too. And then when data quality checks fail, then we can provide kind of data alerting. There's a whole other talk about kind of our secure deployment in the customer cloud. So we are a completely serverless architecture, which can actually be deployed in our customer VPC. So this is just the data in the metadata layer, right? So now the question is what happens to the authoring, like the DevOps tooling layer? And we are just about scratching the surface there, but already we are able to kind of simplify a lot of this what is known as the data ops cycle, right? So we have a bunch of kind of no-code connectors that are very easy to configure. There are SQL-based pipelines with kind of static checks that can find inconsistencies. This is during your kind of authoring. We make it reasonably straightforward for you to debug stuff. We haven't done the kind of the super sophisticated automatically generating pipelines, test pipelines, and so on, although we have all of that information. And ultimately kind of being able to deploy it in the right way and being able to monitor. So all of that actually comes out of the box for us. And what we are able to provide is what we call like observable data pipelines with lineage capture, right? So there's a lot that's going on here. I'll not try to, don't know if we'll have enough time to get to all of it. But the general idea here is, so this particular view is for micro batch processing or batch processing in general. Streaming is slightly different. We can kind of, I can get into a little bit more detail there if needed. But in this particular view, this is more about micro batch processing. So now every little box that you see here is a micro batch that kind of came in from a source or was a micro batch that got updated or that got applied to a particular destination table because that was a transformation. So because our orchestration kind of is completely data driven, so what you see here is kind of what is upstream. So this is a view of for a particular table like this is called, it's an MV, it's a materialized view called customer churn probability. Again, like our customers have built out kind of these pipelines that are they're like 20, 30 layers deep, and they have like hundreds of different transformations in any given kind of DAG. They're able to get like a waterfall for any table in the warehouse, right? And that waterfall is not just a schema lineage, as in churn probability depends on, let's say, a customer deal size or whatever, but you're also able to see exactly how the data got updated for every single time that a table is getting updated, right? So again, we have made a bunch of kind of simplifying assumptions in our implementation around in some sense, kind of discretizing the updates that are coming into the pipeline. This is what your traditional batch processing is, but we are able to do it in micro batches in the sense that it could be like every minute or so rather than every hour or day or something like that. Right? So now, if you had something like this, then the debugging flow is kind of what I wanted to just talk about. Is as you can imagine, becomes a lot simpler, right? So it's the same kind of use case where a business user is looking at a dashboard. They find that there is a problem. They inform the analyst who looks at the dashboard query. If there is nothing wrong with the dashboard query itself, then in many cases we have our customers who are directly able to look at the metadata to see exactly where the problem might be. Like they can go all the way to the source, right? And if they are able to kind of configure the connectors, they're able to do that. If not, they can hand it off to someone else. Or if it's another SQL query that needs to be run, that is run as a transformation rather than as a dashboard query. Even in those cases, they're able to kind of go fix it. And if there is a problem in the source, they're able to directly notify their DevOps teams to kind of debug problems, right? So as you can imagine, this does kind of two things, right? One is it lowers the barrier in terms of the technical expertise needed to debug problems, which in turn means that it can also be done a lot faster, right? So again, in terms of Datacoral's implementation itself, like we're still very much scratching the surface. We are, as you can imagine, in order to build a business, we started off with this kind of overall architecture, but then we ended up narrowing our focus in terms of the product that we are kind of selling right now, like tip of the spear, so to speak, which is what you'll see on our website, which is the CDC connectors or change data capture connectors that are able to synchronize data from production databases like Postgres, MySQL into data warehouses like Snowflake and Redshift. I'll just talk a little bit about those connectors so that you have a sense for how we have actually been able to leverage this kind of end-to-end data pipeline to build a CDC connector. So for people who don't know what CDC itself means, I'll maybe spend a minute talking about it. The main problem that we are solving for our customers in this particular connector is the ability to replicate data from a production database in a reliable way into a data warehouse like Snowflake. Now, CDC is a specific way in which you can synchronize the data. And I was just kind of talking about this with someone else. Like CDC, in some sense, kind of elevates the game for data integration. So it's CDC has been is a technology that has been around for a while. Like production databases, when you're making changes to tables in a production database, these databases write out these change logs, right? So every change that you make to a database gets written out into a log. And CDC is essentially the process of reading this log and then doing different things with it. And one of them, which is a data integration use case, is taking those logs and applying those changes in a destination data warehouse like Snowflake. So now turns out CDC itself is a pretty kind of a deceptively hard problem to solve. So it does require you to kind of think about a lot of kind of different things that you need to do in order to get like a robust solution. One is just syncing data in a historical, like syncing all of the existing data that was there before kind of going to the capturing of changes kind of part of your connector. How do you kind of apply schema changes that you're, how are you detecting the schema changes, and how are you applying in the destination? And then clearly the main one is kind of applying the changes themselves. We are able to provide data quality checks because we have an end-to-end pipeline implementation. So that is what we've been able to kind of leverage to build out kind of fairly robust CDC connectors. So I think covered kind of most of what I wanted to talk about. I'll kind of wrap up here, and I'll see if there are any questions that we can take.
Awesome, thank you so much, Raghu. I think that's been a wonderful presentation, and it just to kind of before we dive into some of the questions that have come through on YouTube, and feel free to keep asking them. We'll just have a quick couple of minutes for questions, because that's usually the most interesting part. Although this has been a fascinating presentation, love the concept of metadata first sort of data pipeline, if I could you know, summarize it to that point. But yeah, there have been a few. So Noel, he's actually my brother, he's asked, does Datacoral compete with like metadata management, data catalog tools? Do you expose that metadata, you know, to externals, so that it sounds like, you know, you're capturing metadata on the fly with like schema evolution and things like that, and that sort of drives how you're pushing updates to production. But also, say, if you can imagine like a data analyst or a business user that's just kind of like, you know, new to the business and wanting to know about a particular data set, can they somehow interact with this tool and this metadata and actually find out what data is available for what?
Yeah, so as you can imagine, we are capturing a lot of like really valuable kind of metadata. We have built out like our own web app where we are able to show a lot of this information for somebody who wants to kind of understand what's going on. And also this metadata is also available through an API, so that it can actually get published into like any of these other metadata tools that are out there, right? So our entire kind of orchestration and pipeline metadata kind of system, it also can emit events or data events, so that those can be consumed by any of kind of the metadata or catalog tools that are out there.
Awesome. A few folks, we probably don't have time for a quick demo, but a few folks have asked for one. I mean, we've got our data engineers Slack group and stuff like that. If you do have like a video or anything like that of, you know, how this all works, or perhaps we can get you back later on in the year.
Yeah, definitely happy to share with you like a video of the demo, and also actually specifically around these CDC connectors, just like a quick plug here. So we actually came up with like a new UX for kind of how CDC connectors work. So if somebody is willing to actually beta test it for us, we have like a gift card that we're kind of giving out as well. So if you know what CDC is or want to learn what CDC is and you want to test out our connector, we'd love to kind of have you kind of experience it yourself too.
Yeah, I mean, if you want to post the link to the CDC connector in the Slack group, or just send it through to me, and I can organize that. I might even put my hand up just to take a look. Do you just host it on some sort of container management tool, like?
Yeah, so it will be inside of your cloud account basically. So because we're completely serverless, we also end up using some PaaS services that the clouds offer. So we are able to deploy our software inside of your cloud account, or we can kind of host it for you, and you can just have like a full-on SaaS experience.
Yeah, cool. Awesome. Well, thanks so much, Raghu. That was really insightful. I've sent around the link with all of your towards data science article and things like that. And thanks once again. We might switch over to Joao Correia. He's going to take us through a bit about Snowplow, which is a fantastic web event capturing tool, and I'm not doing it any justice, so I'm sure I'll just be quiet and let Joao tell us all about it. Thanks, Joao.
Sounds good. Thank you for the intro, Peter. Raghu, amazing presentation. Thank you. Hi, everyone. My name is Joao. I'm going to go through a presentation about Snowplow, what it is, how does it work, why you should care, and when is the right time for you to look into something like Snowplow. A little bit about myself. Born and raised in Portugal, moved to the US in 2012 to pursue a career in analytics. I worked mostly on the agency sides, digital analytics for healthcare.gov, Freddie Mac, Principal, and others. I'm the founder of SnowcatCloud. It's a hosted snowplow as a service, and I work for a Bay Area private equity advising software as a service companies on analytics transformation. I love surfing, snowboarding, and flying, and I watched the Outback Truckers, and it was amazing to learn more about Australia. Okay, so a little bit about Snowplow, what it is. We're surrounded by event data. It's all around us. I find a little disconcerting that we are so concerned with privacy when we're talking about the web. And there's this ITP and all this move towards privacy, but no one is talking about the data that our smart TVs are collecting that we accepted without even watching. Um, our wearables that sends all sorts of data from health to location, even our appliances, our internet service providers, which collect all the websites we visit, and even cars. So event data is all around us, even in industry. It's used, for example, for predictive maintenance for engines. They track engines in real time, their performance, so it serves to do predictive maintenance. I'm going to focus mostly on the use of Snowplow for a universe that is very familiar to me, which is mobile apps, web apps, advertising, and software. But Snowplow can be applied to IoT and pretty much anything as long as it's digital. So let's go back a little bit. Let's understand why and where Snowplow is coming from. Early 2000s, open web analytics, AW stats, Webalizer, you probably remember this. It was a Perl script that generates statistics based on Apache log files. The most basically stats as a product. It printed out a web page where you could see how many pages visited, which pages they were visiting, all that. It was server side, it was on premise, you had full data ownership, and you have access to the raw event data. It was not for a wider audience, so you needed to understand how to set that up. And that is what led the birth of tools like Urchin, that would later become Google Analytics, and Website Story, who would later become Adobe Analytics. And since then, a variety of other tools popped up, Segment, Heap, Mixpanel, Pendo, and in one way or another, they democratized analytics and analysis, web analytics in general, in exchange for, this was mostly Google, in exchange for a very simple tracking JavaScript code. Now you have all this information at your fingertips and for free. That's amazing. That's what we've seen, is really a democratization of analysis as a product. The one thing to have in mind with this is, while this serves a wide range of people, especially if you don't have any skills in what relates to data, CPU and storage, thanks to cloud computing, have never been this cheap. So a democratization was bound to happen. If CPU and storage is cheap, why shouldn't we own our own analytics platform? And that's where Snowplow comes in. So Snowplow is an open source event tracking platform that allows you to track events. And in here, you're seeing more as the next layer in democratization. So in the mid layer, you don't own the data, but you own the analysis. And what Snowplow is doing is allowing you to own the platform. Imagine if you own your own Google Analytics, where you make the rules, you have full control over your data. And that's what really Snowplow enables companies to do. I would say that the Snowplow is not for everyone. Today's market share is still here. So a lot of the things we saw, like we see like mixed panel funnels and forwarding of events, all of this is possible with Snowplow. It's just that it requires some engineering effort, some people effort. If we look at the diffusion of innovations curve, Snowplow today is used by innovators. If you're, and you will see on the companies that use Snowplow are really young tech startups and companies that really get data and see data as an asset, as a competitive advantage, rather than a marketer that just want to make funnels. And I say this, although it's not politically very correct, but if a company today is onboarding the Google Analytics 360 or Adobe Analytics, they're not ahead of the curve. A typical modern analytics infrastructure, I didn't put any vendor names here. I don't want to be very specific. There's variations to this, that's obvious, but Snowplow sits here as an event collector, parallel to any extract jobs you might have from other data sources. So if you want to collect proper event from your mobile application or on your website, you would use something like Snowplow, and then it feeds into your normal data infrastructure. So what is Snowplow anyway? So Snowplow is composed by these key core components. One of them is trackers. Trackers are pieces of code that you install on your application in order to send events into Snowplow. The core, or one of the first components of Snowplow, is a collector. A collector is basically an HTTPS endpoint that receives the information from the trackers. What page the user was seeing, what was the timestamp, all of that information is sent to the collector. Tied to the collector, we also have webhooks, webhook support. So Snowplow enables you to receive events not just from their own trackers, but also from third parties. So if you want to post an event with a particular payload, you can. And this happens in near real time. So Snowplow is by nature a real-time data pipeline, event pipeline. From the collector, it goes into a component that can enrich the data, do things like masking an IP address, using that IP address to look up in an API for location. So you can enrich the Snowplow data in real time. You can also enrich it after the fact. So let's say it goes into a database and you can do a join and enrich it in a sense. So the enricher is that component that enables this to happen in real time for the Snowplow pipeline. And finally, the data is output into storage, and it supports a variety of storage mechanisms by default, from Snowflake, Elastic, BigQuery, S3, Redshift, Databricks, other Kinesis Stream, Kafka, you name it. So because you own the infrastructure, it's relatively easy to forward these events where you need them the most. This is very specific. I don't want to dive too much into this. This is my company, SnowcatCloud. What we do is we provide companies with a managed hosted environment where they have their own collector with their own domain, and we just forward the data into their Kinesis stream, into their Snowflake, their BigQuery, their S3 with full data ownership. You can also set up and download this, but we found that especially in smaller organizations or that do not have the resources to maintain a data pipeline, our solution is very cost effective. Who's using Snowplow? A bunch of companies. These are not our customers, I wish. Some of them are using open source, others are probably using Snowplow managed services. You can actually see how they're tracking by, if you Google Snowplow Analytics Debugger and click on the first link, there's a link to the Chrome extension, to the Chrome store. We actually built an extension that allows you to go into these websites and see how they are tracking events. We talked about this. We can track events. Snowplow can track events from pretty much anywhere. It has, I think as of date, like 20 different SDKs. So you can track events from client side using JavaScript, from server side, IoT, pretty much anywhere. Why do you want Snowplow? One, there's the cost component, although for a large number of organizations, even 150,000 is not too much money. For others, it is. The one thing to have in mind here is when you're making an investment in, I don't believe in silver bullets. There's some tools are sold as a silver bullet, as they're going to solve everything, but you forget the human component. So for example, in Google Analytics, just going into Google Analytics 360, it costs at least $150,000 a year. And that does not include consulting. It doesn't include anything. It basically, you have a couple of more reports, you have unsampled data, you have access to BigQuery, which now they give away for free. So if you are an organization and you care about money, you might want to spend 50,000 on Snowplow and spending the other 100,000 on people. And then you have smart people to leverage data. You need a balance between the two. Am I going too fast? Like, if there's any questions, Peter, feel free to interrupt me. Like, no problem.
No, that's fine. Yeah, carry on. Yeah.
Sounds good. There's also, because these products, if some of these products, not all, I'm not trash talking any product here, but some of these products have, they had an evolution in a legacy. They have certain architectural decisions when they were created were valid, but they don't make much sense now. Like, for example, Google Analytics had the V3. Now they launched the V4, but the V3 had a limitation on 200 custom dimensions. Why 200 and not 500? Why not 1,000? Why the limit of 500 hits per session? And plus, you have to deal with Google decision making, where this month we're gonna throw away the network identification. We don't want you to know network. And tough luck if you're using that data point. It's like goodbye. They don't care. I don't think that's cool. And a lot of data leaders, they don't think that's cool either. And that's not acceptable. Just because you're Google, you can't just do whatever you want. So owning your data pipeline for some organizations becomes a necessity.
Just on that one, Joao, because, you know, the target audience, you know, of the meetup is largely sort of data engineers who may or may not be in the digital analytics space, and may or may not be sort of pulling on the purse strings in an organization. But I guess they can make sort of recommendations. I guess, without sort of, turning it into a bit of a sales, pitch sort of thing. I guess that the key selling point for Snowplow, whether you go to a managed service or a SaaS offering, or whether, you go to the trouble of hosting it yourself, you want to sort of get up and running or something like that, on your own or something like that, is that I guess Snowplow just offers you a lot more control, and you're not beholden to sort of, I guess, some of the, machinations of, say, Adobe or Google or Segment. I mean, not that, there's anything wrong with those companies. I guess, Snowplow just has a different, perhaps more flexible open source offering, I guess.
Yes, what you gain, again, I'm not saying that these are great solutions. I'm not saying these are for everyone. There's drawbacks with Snowplow, as we'll see ahead. What I'm saying here is that Snowplow will allow you full control over your data. And sometimes some organizations, that is necessary. That's all I meant with this. I'm going to dwell too much. So here we go. Pros and cons of Snowplow. There's no user interface. If you're from a data engineering perspective, this is one of the big cons and one of the big advantages, I would say, of Snowplow, because it turns away people who should not be touching this. Okay, let's dive in. What's the problem with the interface? I've worked many years with large enterprise organizations with Google Analytics. The one thing that happens is there's this I would say tendency to self-serve. And in the tendency of self-serve, people are going to the interface and they're going to start asking questions that do not make sense, taking conclusions from the data that do not make sense, and trying to politicize data and trying to twist the data to fit their story. That's why I can't hear the phrase like data storytelling. For me, that's like a big no-no. Like, stories is what we tell our kids before bed. Data is facts, it's hypothesis, it's reproducibility and observations. It should be very black and white, and questions should be centered around business questions, not data requests. And when you give a stakeholder a user interface, they're going to go sideways. It's going to go sideways. So if you sit down with that stakeholder and have a one-on-one conversation, what is exactly you're trying to know? What's the business question? And you distill that business question, you will be able to add a lot more value, validate the insights and the analysis that you're giving into a piece that is reproducible. The other end, and I've seen this happen over and over again, is someone goes to the interface and asks, hey, can you give me these numbers? They'll get you the numbers. You ask the same people, the same person, or a different person at a different date for the same numbers, and they'll get you different data. So it's not reproducible. So you want to create reproducible analysis. Not having an interface is a way to achieve that, and focus on really matters, the business question. But for some organizations, let's say, for example, product managers, they want to see funnels, they want to see count number of events, basic stuff. Totally agree. Something like iterable, segment, amplitude, amazing use case. You can use that product to create those analyses and productize those analyses. Other con, it requires ownership of the infrastructure, which is a good thing and a bad thing. Unless you have, so if you engage with our services, you don't actually need ownership of the infrastructure. You need to have a data warehouse, of course. If you do managed service, you need to own your infrastructure. So not all organizations are at that stage of maturity. It requires analysts who know SQL. In the digital analytics space, there's a lot of people who call themselves analysts but don't know SQL. So that's something to be aware, that a Google Analytics analyst or an Adobe Analytics analyst does not necessarily know their way around data and SQL. So that's another requirement. And again, requires a visualization layer. I'm sorry, I'm turning all the disadvantages into advantages, but here's the thing. Organizations today, what do you have? You have vendors, domos, Sisense, a series of players that what they're trying to do is they're trying to aggregate. Oh, we do ETL, we do transformation, and we do visualization. But then you have the web analytics in another platform, and all of a sudden there's 5 different visualization tools that a single organization use. A mature organization has 1 visualization layer, maybe 2 visualization layers, and data is in one location that serves. And because data even integrating with other sources, it increases their value. So having 1 visualization layer is the way to go, but not everyone is at this stage. Something like Tableau, Looker, Power BI, modes analytics. Again, this requires another level of sophistication. How are we on time? Good?
Yeah. Definitely got a few minutes. Just
Okay.
I thought I'd jump in and ask a question there, because I think there's a school of thought in data engineering where you really should separate things into layers, where you've got, like, say, your ETL layer, your warehousing layer, where you're sort of starting to, form that data into business constructs that are well known. And then, you've got your analysis layer, and then maybe your presentation, your visualization layer. And there are tools, that try to sort of put all of these things into the one sort of package. And rightly or wrongly, like Domo, for instance, it seems to kind of do the ETL, and then sort of the massaging and also the end sort of visualizations and stuff like that. And from a sort of a data engineering DevOpsy perspective, I'm sure these products work amazingly well for many organizations, but
yes,
something from my perspective where I'm kind of not very comfortable in that sort of environment. Maybe it's because I don't have as much data engineering work to do or something. I don't know.
I'm not, this is important. Like, I'm not advocating that Snowplow is for everyone. I'm saying like Snowplow is not for everyone. And I have a slide just on that, but it's important to know these pros and cons, because if you're on an organization and you're a data engineer but you don't have data analysts and you're already overworked, it's not really realistic to go into Snowplow unless your leadership has a vision on using data as an asset and they see data as an asset. So it's important to understand these drawbacks of the tool. Of course, we walk through some of these things: full data ownership, real time, track across platforms in a single location. It's loved by data professionals, runs on the clouds. And something that comes up increasingly today is it's less likely to be blocked because you have a first party domain where you collect your event level data. Currently, you see event tracking into third party domains like Google Dash Analytics or Segment. And for example, Safari is going to cap the duration of cookies for 7 days. So if you're doing attribution and if you have a sales cycle longer than 7 days and you're heavy on Safari users, the data is not likely very accurate. But, caveats. Okay, moving on. When is the right time? Sure, analytics maturity. We see organizations that go into Snowplow, like people really get it. They did their research. They've been with GA or Adobe, and they did a bunch of, they went through a series of product updates and data breakages, and they see like, okay, now we really want ownership of our own data, of our data. Now, is Snowplow a good fit for you? Yes and no. No, let's start with the no. No data team or lack of knowledge. That's a deal breaker. Like if you do not have a data team or you lack SQL knowledge, do not go into Snowplow. You do not have a budget for analytics, meaning you're tight on money. Like Snowplow, it's not a tool for you because the tool itself is accessible for what it is, but it's going to be heavy on the people side. You're going to need people to leverage this. Or if you just like, you see there's no data culture, you lack a data culture and analytics not being a priority, Snowplow is not going to be a fit. Usually we see companies, the VPs of Eng, the CTOs and the founders, people who have a stake in the game in terms of P&L ownership, opting with Snowplow, doing research and saying, we want Snowplow because we see data as an asset. But from a marketing perspective, it's less common. You see, or a product manager, they go into products that like a heap analytics where you drop the pixel, it's going to track everything and you can draw your charts in. It's more immediate and you can almost self-serve without the need of having a data analyst. So the bottom line here is Snowplow is not for everyone. Some things to know: how do you implement Snowplow? It's not much different than you would implement any other tools like Google Analytics. The SDKs are very similar. There's a thing called schemas. I won't go into that, but basically one of the magical features of Snowplow is you can attach a context to an event, meaning a person is going through a door, you say this was a person and the action was passing through a door. So you can attach as many contexts as you want to what was passing that door and reuse these contexts around across your digital properties and be consistent. So basically you can track everything in a very organized fashion. The schemas are documented in JSON files, so you get documentation right off the bat. If you want to integrate with other tools, I expect to see integration soon. A typical Snowplow deployment, you provision Snowplow, you build the taxonomy of the business. If you're selling cars, you want to make sure you're tracking the car brands and all of that and create schemas. You go into implementation, data modeling and visualization, and you can opt to continue running whatever you're running to serve marketing and have Snowplow to inform, for example, to do real-time collection, to inform the products, or to empower your data scientists. You can actually, it's okay to run both at the same time. Deployment options, SnowcatCloud, which is us, no lock-in contract, simple and fast to deploy, cloud costs are included. You can go with Snowplow Managed Services. They have an application that you deploy on your AWS account, and everything is under your AWS account. You own everything. There's an additional cloud cost, of course, your AWS usage, or you can just go ahead and download it, the open source Snowplow, and run it yourself. One word of caution regarding this is be friendly to your executive team and to your company, the company you work for, and be honest about this. If you are the only person who understands snowplowing in the organization, what is going to happen when you move on to another company? Think about business continuity and like if you're the only one, at least train another people to be able to manage and maintain Snowplow for the organization. You don't want to leave the baby in someone's hands with no food. Okay, that's it.
Awesome, thanks so much, Joao. I think that was really cool. You know, it's we're a bunch of data engineers here at this meetup, so oftentimes, as I mentioned before, we're not making the financial decisions within an organization of where to spend money on some infrastructure. Some of us are, you know, the digital domain can be in different teams than us, but I think it's really cool to sort of get a bit of a glimpse of the different types of digital analytics tools that you can use. You know, Google Analytics is not the only option out there for you, and it sounds like, you know, with Snowplow you can do, I guess, you know, a bit more granular, sort of low level stuff with your event tracking off your website. You know, you mentioned you can sort of, I think most of the tools you can inject things like user IDs and different, you know, bits and pieces, but it sounds like you've got a little bit more flexibility and stuff like that, and you can, you know, ship all of the raw data through to your website, warehouses and stuff like that, which is cool. So yeah,
I can go into a very quick 1 minute demo of Snowplow. Something you could do yourself is you can download Snowplow Mini. They have an AMI on AWS, so you can go select public from the AMIs, search for it, and you know, install on your AWS account. Basically, it's a self-contained Snowplow Mini instance EC2 with a Kibana front end where you can see the events coming in real time. And this is how actually you can debug. For example, here we are on our website, I can say forward our production collector into our demo collector, if you say, and whenever we fire an event, you can see the event here, everything that is being sent, and you go here and you see the events, you expand, and you can see all the data that you are collecting. Yeah, this was a 1 minute demo of Snowplow, so it's really easy to get started and see how it works.
So does that AMI come with a Kibana Elasticsearch?
Yes, yep, exactly. It's just It takes 5 minutes to deploy it, and it's up and running. It's a Snowplow collector. You might have to fiddle with HTTPS, with certificates for HTTPS, but yeah, it's pretty easy to set up.
Then you just need a website to inject a bit of code into or something like that, and you're done.
Yeah,
No, that's really cool. Yeah, like I said, that's great. Thanks so much for taking us through it. That's kind of what the meetup's all about. Sort of learning about new tools and things like that. So thank you so much. Thanks to Raghu as well. Two awesome products, lots of innovation, let's face it, happening over there in the Bay Area. So hopefully we can return the favor and sort of start developing some really cool data engineering innovations here down under. So stay tuned for some cool talks. I'm sure we've got them in the pipeline.
Does anyone has any questions?
We didn't get any through on the YouTube. There was a comment saying, is there a CloudFormation template to spin up?
I just replied, yeah.
Yeah.
Yeah, not that I know of. I know Snowplow has Terraform, but it's not public.
Yeah, I can imagine. And it's probably, whether you go managed or spin it up yourself, but then you've got that AMI if you just want to quickly test something out. That makes sense.
Yep.
Very good. Well, we've got another meetup on tonight at 6 p.m. So that should be very cool. We're going to learn a bit about LakeFS. So stay tuned for that one. In the meantime, just feel free to shoot through any sort of questions that you've got on our Slack group another big round of applause to all of our speakers. Thanks so much.